So we were asked to evaluate this improper integral, and the definition involving limits is written on the right. So we have the integral from a to infinity of f of x with respect to x is equal to the limit as t approaches infinity from a to t of f of x with respect to x. So we can rewrite this example as the integral from 2 to infinity of x to the negative third with respect to x. And now rewriting this using the limit definition, this is equal to the limit, and I'm just going to use b instead of t, so as b approaches infinity of the integral from 2 to b of x to the negative third with respect to x. So this is going to be equal to the limit as b approaches infinity of, so now we can evaluate the integral. So we add 1 to the exponent and then divide by that result. So we have x to the negative second over negative 2. And this is from 2 to b. So this expression is equal to the limit as b approaches infinity. So now we can just simplify this. So we have negative 1 over 2x squared from b and 2. And then finally, we can write this as the limit as b approaches infinity. So now we substitute in b and 2. So we have negative 1 over 2b squared plus 1 over 8 when we substitute, because we're subtracting. So when we substitute, we have negative 1 over 2 times b squared, and then we're subtracting negative 1 over 2 times 2 squared to get that result. So when we evaluate this, we see as the limit goes to infinity of the first expression, the denominator is going to get very large and the top stays the same. So this is going to go to 0. And then for the second expression, it will go to 1 over 8. So the answer is 1 over 8.